Mi gato se está quejando que no puede vacilar.
Method of partial fractions. So personally, I find these problems particularly fun. As I said before, I like math, so even though it might sound weird. So these are partial functions. So this is what we're going to be dealing with here. Okay, so partial functions, this is like a function that you have that you can represent as a p of x over q of x. And you might be wondering, like, where did these random letters come from? But it's basically just saying that one thing is over another thing. Some function of x over another function of x, okay? So this actually usually looks like, let's see, what are we going to say? So this could look like a p of x, so some function on top, right, over, and then q of x could be something like, in your problems you might see something like this. So the a's in this case, they're all constants. So then something, 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 as far as up to a n, when you have n many terms on here. So if n is 3, then you'll have 3 sets of parentheses on the bottom. Okay, so anyways, our job is basically when we're given an integral, or an integral to evaluate, they'll give it to us in the form of usually either this thing, sorry, that circle was supposed to go out there. Okay, so either in this thing, or even like this, or like this, okay? But our job, why do I have random integral sign? So anyways, our job is to decompose it, so ignore the integral sign. So decompose. So we're going to decompose one of these 3 forms into something that looks like, into something like a over x minus a1 plus b over x minus a2 plus dot dot dot, to fill in the dot 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 there, and then c or something over x minus a to the n. So written like this in terms of variables and things, it looks kind of confusing, but we'll see when we actually apply it to a problem how, I guess, simple it is actually. So the whole point behind this of decomposing is to make, because in these forms, as fractions added together, the whole like partial functions, so partial referring to fraction, it makes it easier to integrate. And oftentimes you'll see that the thing on the bottom is going to turn into ln once we integrate. Okay, so another thing that I'd like to address is finding common denominators. So common denominators, well, finding, okay, so finding common denominators, no, I put demon, shoot, okay. I'm just going to try that again. Common denominators is key. Okay, so this whole thing about like adding fractions and whatnot, having to find these common denominators, that's what drives the whole process that we're going to be going through. Okay, so let's try an example, and I'll show you how to walk through it. So let's say we're given something like x over parentheses x plus 1 times x minus 2, and then our dx. Okay, so as you can see here on the bottom we have 2 sets of parentheses with something in them multiplied together. Okay, whoa, I moved the screen, that's weird. Okay, so on the top here, that's kind of like our p of x, right? And the bottom, composed of parenthesis stuff, is our q of x. Okay, so what we want to do here is decompose this. So turn it into something that looks like a over the first set, right? X plus 1 plus b, which is some constant. A and b are constants, over x minus 2. You can write the parentheses for kicks, I guess. Okay, and then the whole dx at the back. So here's the process to doing this. As I mentioned right before this, finding common denominators is key. So if we want to actually add these fractions together, what we'll have to do is get common denominators. So we have our a over x plus 1. So if we want to add it to the b part, we have to multiply top and bottom by x minus 2, right? And then same thing for b, which is already over the x minus 2, but now it needs the x plus 1 on the bottom. So bottom and top, like that, right? Simple fractions, okay? Then we have our dx. So as you can see, once we combine these together, once we add them, I'm going to go up here. So on top, we're going to have a times x minus 2, right? Plus b times x plus 1. And then all over our common denominator. Okay? And then, oh geez, there's a dx over here too. Okay, so as you can see on top, now we have some combination of a's and b's and x's and other numbers. And then on the bottom, that looks, well, I switched the two order, but that it looks exactly like our q of x, right? Because we have x plus 1, parentheses, all in parentheses, times x minus 2, okay? So basically what we can do now is equate our x, our given p of x, right, the thing that they give us on top, to what we found in terms of a and b. Okay, so I'll continue this on the next slide. So what we're going to have is actually, so on the top we had a times x minus 2 plus b times x plus 1 equals our p of x, which they gave us as x. Okay? So in this case, we can just distribute. So ax minus 2a plus bx plus b equals, this is like a 1x, right? And then we don't have a constant, so we can consider that as 0. Okay? Alright, so now let's combine like terms. So we have a plus b times x, right? The ax and the bx. And then we have a negative 2a plus b. Yeah, so as far as this goes, I just like combining the like terms, because then what we're going to do is make the coefficients equal to each other. So see how on this side, the coefficient of x is a plus b, and then on the right side, our coefficient is 1. And that's the only x that we have on this side. So a plus b, consequently, has to equal 1. Okay? And then we're going to do the same exact thing with the constant on this side, on the left, and the constant on the right. So we're going to kind of set up two equations here. So this is a negative 2a plus b equals 0. Okay? So, now it's kind of like a system of equations thing, but it's pretty simple. So what we're going to do is we get b equals 2a, right? And then we could plug this into the b spot. So we have a plus, now b is 2a equals 1. And solving this, we get 1 over 3. Okay, and then we plug back in here to solve for b, and we get b equals 2 over 3. Okay, so now we're almost at the final step. Kinda, not really, but okay, we'll see. Yeah, so once we found our a and b, we can plug it into the partial fractions equation. So now, so here's our initial thing. The first thing that they gave us, x plus 1 and x minus 2 on the bottom, and dx. So now we know this is equal to a over the first thing. So what we found for a was 1 over 3 over the first denominator. And then for b, we found 2 over 3. And then all of this is times dx. Okay, so now we can actually integrate. And here's where I was talking about ln's and stuff. So these constants, they're kind of just there, and they just come out in the integration. So we have 1 over 3 ln, absolute value x plus 1, right? And then added to 2 over 3 times ln of the second denominator. And then, of course, plus c because it's an indefinite integral. Okay? So, yeah, so that was like the basics of partial fractions, integrating with partial fractions.